All right, this is Dr. Parson. I believe this recording is going to have audio in it. At any rate, it's October the 20th. I'm running out of time, and so I'll show you all where I got with this sketch. So, current name of this one, Gravity 2019 Underbar October 20th. And we now have 5 tabs in this thing, one of them being the main program, one of them being the place where the commands are processed. We had that one before. One of them essentially being the planet class. And this one is primarily Angela's domain. Most of the fields that were in there before are the same. However, I have added 2 helper classes to this. One of them, a helper class called Moving Body Physics, and there's an object of that class that is constructed right here in the constructor for the main planet class. And when it's constructed, it gets a reference to the planet object. And likewise, there is a helper class planet assets for visual assets. And similarly, that's constructed from this constructor and passed a reference to this planet. Those things really only get used in 2 places, and I think this is the only places that they should get used, but we'll see. Physics gets used during planet movement. So planet movement consists entirely of calling that helper object, and I'll show you for now what that does. It doesn't do too much, but assets gets called right here in the display function for the planet. And so it actually puts the shape out. Todd had mentioned being interested in using 3D spheres and textures and so on to get more visual accuracy, but also visual appeal, more aesthetic appeal. And so that is where this would go. The main framework display function sets up all the coordinate information, and then I'll show you what goes on inside of the, since we're on the assets one, I'll show you that. Not a lot to it. Does a push and a pop matrix so that if it has to do anything like scaling in this case for a sphere, those changes are isolated inside of here. If it needs properties back on the planet, it just goes back and reads the variables, the appropriate variables, in this case size variables. And so it can read any of the data fields back in the planet. It has access to those. The physics, and there's a bug in this right now, but the physics similarly goes back and can read data fields in the planet. So everywhere that you see the PL dot prefix, it's reading properties in the planet. This is still using the same logic that I had in my handout code initially, so I haven't added any new physics to this thing. And so it's just figuring out the next location in the planet's orbit based on a speed that's in pixels. And then based on that, just figures out where the planet should show up next time around. Again, I do have a bug with this that needs to get resolved, but it's not a showstopper. And that's really all this helper class should do, is basically figure out, based on the current mass and the current, well, probably just mass, density and size are related, but that's the main, well, yeah, current mass and speed, and whether it's captured by the planet or by the star or not, where it should go next. I haven't put any of those physics in related to either mass or other bodies in the planetary system, so haven't got to that at this point. Something else I want to mention about commands, since I made some changes in here, is that the intent of interpret key is to interpret a single key command coming from either key pressed or across OSC, Open Sound Control Network, from an Android. So therefore, I have key pressed. All that key press should do is just call that helper function. Shouldn't do anything else. All the logic should be inside of interpret key so that it doesn't care whether it's getting that command from the keyboard or getting that command over OSC. Similarly, interpret string, which right now doesn't do anything. The intent is that sometimes I will build up multi-character commands inside a key pressed and then shoot them into an interpret string function when the tester hits new line. But if you send full string commands over from Android, this is where they would get routed. So the idea is to route either keyboard commands or OSC commands through interpret key when they're single character commands, or through interpret string when they're string valued commands. Haven't got to that yet, but it belongs inside of commands. And finally, I guess in terms of code changes, I mostly used Angela's code base because it had the orbit information in. I've changed some things inside of here. Took them out of commands and put them, I think, well, I'm merging a couple of sketches, merging what we were doing in 3D with CS220 and this. And I'll give you a demo, but I made some tweaks to the main draw function, including figuring out, for example, if we're taking the square root in order to figure out distances, and that's not what we're in right now, to do it here. If we're linear, I don't have a separate variable now because either we're squared or we're linear. So if we're not squared, we're linear. So if we're not squared, and previously we were, again, clear it out, replot them, and set that flag to the opposite. So that stuff's going inside the draw function because I was seeing some glitching in the graphics because basically you'd hit keys and things would get redrawn, but sometimes they wouldn't get redrawn at the right times, and then we would redraw them multiple times. And that's the reason for these last variables, is so that we don't get glitching. This is going to have to change when we allow users to insert new planets on the fly, because then they're going to do the adds of the planets. But right now I didn't get to that point. That's going to happen interactively from Android. Part of the intent of this thing is to be able to add planets on the fly, people sitting in the planetarium. And one caveat about that is that it's not going to be possible really to predict the details of the graphics, although you could make up details based on whether it's a gas giant or a small rocky planet and do texturing based on that. So we may need some way to pass that. I mean, that information partially is in the mass and the density, but we have to have some way to figure out. We won't necessarily have fixed planets like Mercury, Venus, Earth, and so on. When this thing is in its final state, we'll have planets that get thrown into the system, and we can just distinguish between relative sizes among gas giants and relative sizes among rocky planets and not get too sophisticated about that. But they won't necessarily be the planets that we have in the solar system, although that is a good starting place. Now, since we have company coming to dinner, I'm going to demo a few things, including a bug that I don't have time to fix now, but I'm going to leave the functionality in there because it's something that can be fixed, I believe, at some point inside of Planet Physics. So off we go. There it is with a linear plot. If I hit Q, it goes to the square root sizes, and if I hit L, we go back out. And so you can see that going to the square root helps to expand the apparent space in at the center, and going to L brings us back out again. Another thing we can do when we're with linear is we can move the camera point of view up. Now, the only problem with that is now the inner planets really get smashed in there. And these sizes aren't necessarily, well, maybe they are. I used the sizes that Angela provided, but I used the spheres based on Todd's preference to do some work with 3D. So those are actually spheres going around right now. I'm going to go back to Q. Navigate around a little bit. Here's east. Here's west. And this all carries over from code that we did with CS220. I added capital R for reset to get us back into the starting position. North and south. So Angela had these in. Let me reset again. And I re-added the ability to rotate the apparent solar system around the X and Y axis. This is where the bug is right now. But if you don't do that, you can't see the sphere, for one thing. Let me navigate down through, first of all. So I'm going to go down through and come out the other side, which had the effect of reversing the side that apparently the planets were on, and also the direction. So you can see right now they're all going clockwise, but if I go back up again, they're going counterclockwise. Now, ultimately, we may have some planets that get captured in retrograde motion and backwards motion, but we won't worry about that for now. Reset this thing. Okay, here comes the bug. I can rotate around the x-axis, but watch what happens to the correlation of the planets to the ellipses. It's thrown off. You can't see it if we get edge on, because you can't see that they're out of line. Reset it. Rotate around the y-axis, same problem. I have fussed with this for most of an hour. I've got to do some 3D trig that I thought I could get away from doing. I thought I could let processing do it, but apparently processing won't do the whole thing for me, and I'm running out of time, so I'm going to post this as it is. But we do want to have the ability to rotate around these axes, and the reason for that is so that we can go zooming in from the side and see the spheres and see any details that are on the spheres. In fact, that's probably more important than having these things aligned perfectly with the ellipses, but there's no particular reason that we shouldn't be able to align them with the ellipses. Unfortunately, right now, the only time that they're perfectly aligned with ellipses is when you haven't rotated around the X or Y axis. I took out the ability to rotate around the Z axis because it's just confusing. They're already doing that, and if I rotated around Z, it would spin the whole solar system clockwise or counterclockwise, depending on the direction. But I found that confusing to use, so for now I took it out. But the other two, here's rotate around the X. We'll go the whole way around. And it took a while to get the trig for this bugs out of it. Here's a rotate around Y. But again, you can see the planets are going off of the orbits. And so I have not factored in 3D rotation into computing the physical XY locations of these things. And that stuff all happens in that tab associated with the move function, the one that does the physics. So, but it's great fun to play with. Go back out to linear, and then if you go up, I mean, this highlights some issues even more pronounced, because we've got this giant bulging star in there, which, I don't know, maybe it's too big. Maybe it's just not to scale, but maybe it is. I suppose that Mercury gets awfully close to the sun. So, I'm not sure about the sizes, whether they need any tweaking or not. We'll fly through the sun, come out the other side. So that's where this thing's at right now. I'm going to post this video, I'm going to post the zip file, and then go out to dinner with some family members. And if you have any questions, let me know. Thanks. Yeah, that bug would be in planet physics, because that's where the move calculates the next screen coordinate for the planet, and so therefore needs some additional trig to get that to work.